Hello, welcome to Google Earth for land development. This video will go over the free program Google Earth and how it can be used in a land development application. Firstly, Google Earth is a free program available from Google that will allow you to reference, work with, and share georeferenced information in a less precise format than CAD, but in a more accessible method for the average user. Before we begin, a couple of small notes. Firstly, if you're having any graphical issues, which is common for people with older machines, this can often be fixed by going to Tools, and then Options, and under 3D View, under the Graphics mode, either switch from your existing mode to the other or activate Safe Mode. This will often limit some of the issues that you might find. Secondly, go to your Navigation tab and change the Fly To and the mouse wheel settings. Now these are by preference, but I do find that having a fly to speed of at least 1.5, if not 2, will save a lot of time when moving from place to place, and I like to increase my mouse wheel speed to about 60%, but you will find that this will change a little bit from person to person. You will also want to make sure that you click Do Not Automatically Tilt While Zooming. This is a function that's built in for Google Earth that makes certain environments more easily viewable, but can be very frustrating when you're trying to look at everything top down. The other thing you would want to do is make sure that Gradually Slow the Earth is turned on. It's again a preference item, but sometimes reduces the motion blur that you can sometimes get and quite frankly dizziness that comes with it. When you're ready, click Apply, and you will now be ready to move more quickly in and out and bounce around from place to place. First, we're going to cover some basic preferences when you're using the software. We'll move to a random urban environment and look at some of the layers that are automatically pre-programmed into Google Earth. Some of these include places, roads, labels and borders, and a few other ancillary options which are less well supported. You will often find that places, borders, labels are useful when you're trying to find the location, and roads are particularly powerful when you're trying to display a location to other viewers of your data. However, all three of these will often get in the way when you're trying to do more precise work, so typically I have these turned off along with all of the other layers that are available. My preference is to work with 3D buildings and terrain turned off. However, there are some applications where 3D buildings and terrain can be useful. So terrain refers to the actual ground surface, and you can notice that there is a slight adjustment in what Google Earth is displaying to me when I turn terrain on, because if you were to look obliquely, it is actually creating a rough surface over which it is stretching the satellite imagery. Now to take that a step further, if you turn on 3D buildings, which requires that terrain be on, you will actually see buildings in a three-dimensional way that can sometimes be useful for understanding the cityscape and looking at various items of perspective. Now, there are some limitations to the 3D buildings option. First of all, it is typically only clustered around urban centers. So for example, if you go to the edge of an urban center, you will often see buildings side by side, which either are or are not 3D based off how close they are to the populated areas. So it's a useful tool, but it can only be accessed in certain areas, which are often in and around the limits of what Google has provided because we're doing land development in and around urban cores. There are also some applications where 3D buildings can be quite useful. If we move to a forested area that is near to an existing development, it can be somewhat difficult to actually see variations in the ground surface. However, if we turn on 3D buildings, we can actually see where the tree cover is and what vegetation is low-lying cover. This can be helpful when it comes to doing surveys of the area, planning field work, or understanding which portions of a property are developable and which portions are not. Now, jumping back to our urban environment, let's look at a few of the functions that are involved when it comes to the satellite imagery that is incorporated into Google Earth. Firstly, by clicking the date icon down in the bottom corner, you can choose from different dates of imagery that you would like to look at, many of which are not particularly useful whether they be too old to actually have usable data, or whether they were taken on a day that was particularly inhospitable to aerial photography, which is why typically Google will choose the best photo to represent that area, and will often blend photos together in order to get the best representation. We'll cover that more later. Now, one thing you will want to note is that when we have a given photo, it will occasionally change based off the elevation that we're looking at that photo. So you can tell that between approximately 30 kilometers and 13 kilometers, it has switched to a different satellite imagery that has a lower resolution. Now, one thing to note while we're at this altitude is that if you turn off the satellite imagery, you will no longer be able to turn it on at this altitude. You have to be below approximately 15 kilometers in order for the altitude to allow for satellite imagery. However, once it's turned on, you are able to zoom out and you will actually see the number of images typically increase as you get to a greater height because you're now encompassing larger data sets. Now moving on to a more applicable development application. Here we have developable land, which is in and around an urban core. We will use this to give some basic examples as to how to use the functions that are built into Google Earth for marking locations in space. Firstly, an example of why we always want to turn off our terrain is if you look at the polygon example, you will see that it actually clips through the terrain in the areas where the terrain rises up, both in the treed areas and in the highlands. In order to prevent this, we can simply turn off the terrain, or alternatively, if we were to go to the properties of the polygon, we can actually increase its altitude to make it high enough above the ground that it won't clip through anymore. However, this does mean that the polygon has to be relatively high up and may actually be distorted depending on the angle you're looking at. We will now reduce the polygon back down to where we originally had it, and we will look at one of the few applications of the ground surface view. So when we have terrain activated, we can move very close to the ground surface and actually look up and out to see an approximation of what the ground surface will look like. This can give a general sense of hills and valleys, but as you can tell, is particularly flattened and will not give you an exact representation of the ground surface. Now, one thing to keep in mind when you're in this mode is that zooming forward is normal, but zooming backwards or trying to move backwards with the mouse can be particularly finicky. So when you're in ground surface view, you may lose your place and have to go back to where you were. Now let's move on to the basic tools that Google Earth offers for you to use. Firstly, before we begin with tools, I would like to put out a disclaimer that Google Earth does not have an undo button of any sort. This means you will want to be very particular about the changes that you make. You will want to have frequent backups in order to ensure you don't lose any of your progress, and you will also want to avoid changing things without some method of reverting that change. So an example would be if you were going to change the shape of an object, duplicate that object first in case that change does not go well. Additionally, if you find that the navigation bar, which includes the Street View option on the right-hand side, goes missing, you simply go to View, and then under Show Navigation, click on Automatically. From time to time, this bar will disappear and will need to be restored. Now for the basic movements of the camera. Firstly, zoom in and out can be done with the mouse wheel. But if you have to move around the screen without clicking, which is sometimes required depending on the tool you're using, you can navigate using the mouse wheel. So for example, by scrolling out while I'm hovering over the top of the screen, you will see that the center of my screen is moving down. Similarly, if I then move my mouse to the bottom of the screen and zoom in on that location, I've now substantially moved my zoom. This can be done on a regular basis if you are doing a long alignment and are required to follow along with what you're doing, and can also be helpful to make sure that you're staying in place when you're zooming in and out. The middle mouse button can also be clicked and has two functions. It can be moved side to side in order to twist the globe, and it can also be moved up and down in order to change its rotation. Effectively, the middle mouse button selects a point on the Earth and moves the camera around it. Then using the control button with a left click, will move side to side and up and down. Effectively, the control button creates a point at the camera and then moves the camera's view around that point. One unusual function of Google Earth is that if you have the camera in one position and move it to another position, pushing the backspace button will take you back to where you were previously. You can also use Control Backspace to move forward. However, keep in mind that even small camera movements will count as a movement. So this and this will be the same as moving from here to here. And sometimes this may not be a reliable way to keep your camera in an existing position. To ensure your camera always comes back to the same location if it is required, you can use a pin, such as I've done here, and make that pin invisible, either by reducing its opacity to 1 or by hiding it within the ground surface by decreasing its elevation. You will always return to the same camera that you had when the pin was originally placed. There are also ways to save your views, but we'll cover that later on during the export functions. Some other basic functionalities include using the plus button and minus button to move the camera in and out small amounts. This can be incredibly helpful when you have your mouse speed turned up the way I have, because you can do gross movements with the mouse and then finer movements with your plus and minus. You can also use the N button to center north at the top of your screen, and you can also use the U button to center your camera directly over top of the middle of your frame. Another useful shortcut for most people is using Alt-Enter to automatically open the properties of that tool, something that we will go over the functionality of later. Additionally, Control-Alt-R will automatically open the renaming function for that given object. There are many other short forms that can be found online, but those are the ones that I found most useful in my practice. Now moving along to the measurement functions that are built into Google Earth. There are a variety of measurement tools that can be used, with the most simple being the line that measures from one given point outwards. By clicking once and then clicking again, you will get a static line, which will be overwritten when you go to do another measurement. This can be a helpful way to measure between two objects, or to simply measure the overall dimension of a site quickly. The path tool can also be an effective way to measure distances that are not in straight lines. If you are, say, planning out future roads or trying to measure the length of an existing road, this is a helpful function. It can also be used to help space things out evenly, but keep in mind that one of the big challenges is when you move to another tool, you will lose the nodes along the path, so those cannot be used particularly for measurements. However, if you are looking to do equally spaced measurements, one of the most effective ways is the circle tool. By placing a point and then using your circle measurement tool, you can measure out how far you want to move away from that line, and then simply place your next stake and repeat the process. This can be done with the linear measurement tool, but is sometimes easier with the circular tool, because it allows you a little bit of range in terms of where it is placed if you're not on a linear infrastructure. And finally, we have the polygon tool, which can be used to measure out areas and returns both the perimeter and the internal area of that polygon, which can be expressed in a variety of formats. Two other tools include the 3D path and 3D polygon, which are exactly what they sound like. They allow you to measure a path or polygon that extends both from the ground or onto three-dimensional structures. So as an example, we will find a structure that has tangible height. We will then turn on our 3D buildings and terrain, and we will start with the 3D path from the ground surface, moving up the wall of the building and across. And you can see that the value continues to increase, even though in plan view, this would be one straight line. This is similarly done with the polygon, where if you needed to measure the dimension of a space, you would easily be able to do so. However, keep in mind that there are limitations. For example, this polygon is actually clipping through the building and would not be measuring the long distance to go to the corner of the building and across the roof. This will also happen with 3D paths, that if they are not drawn directly to a connection point, they will take the shortest path. So if you are looking to measure, let's say, up, over, and down, you would want to begin at the vertex of the building, go to the crest, and then go across the surface. This will give you the actual dimension that you're looking for without losing any of the ground in the middle. Now, moving back to our development lands, there is a functionality behind Path that is very similar to functionality of other tools, where clicking with your left mouse button will add new points, while right-clicking will remove the previously placed points until eventually there are none. If you have a path, you can see that the blue highlighted location is your current location. If you were to select a different one, you would then be placing points that came after that one. And additionally, if you were to select a point and right-click, that would be the first point that would be taken away. So you can move around the shape, but you can't change the direction in which the shape is constructed. So for example, if I had to add points, they will always come downstream from the point that I'm working with. If I wanted to add a point in the middle here, I would be required to select this point and then add it. One of the nice features of using the measurement tool is that you are still able to click and drag the map while you are using it, which is not usable in many of the other tools that are to follow. The first tool that we'll look at is the point tool, which is quite straightforward and the cornerstone of any good Google Earth file. So firstly, we will place a point icon and give it a name. In this case, it's going to be a borehole. We can then select what we want the icon to be from the preset list that Google provides. It is possible to use custom icons, but there are sometimes issues associated with where those icons are centered, and it often is easier to try and work within the existing framework. You can also set the color of those icons where they don't have color options built in. So for example, you can set an entirely red pin. You could also use a circular indicator, which allows you more flexibility in selecting the color that goes along with it. Sometimes you will note that the color of the pin will not actually change until you have completely exited from the properties, at which point it will. You will also note that the color is not correct over here in our places. This is an unusual quirk of Google, but as long as you see the right color on the screen, that will carry through to any of your exports later on. You are also able to change a variety of factors related to the pin, including the color that you want the label to be, the scale of that label, and the size of the icon itself. You are also able to change their opacity. So if you wanted them to be more difficult to spot, or in some cases, nearly invisible, you can turn the opacity all the way down. However, entering an opacity of 0 often can create some issues where an opacity of 0 does not show up on any of your exports. So if you want something to be invisible but still captured in a legend, put your opacity to be 1. When placing a variety of point tools all at the same time, try placing, describing, and then setting your point. If you were to place, move, and then describe your point, you will be required to go back and select the name in order to give it one. So it is often easier to select the tool, give it a name, and then move it to where you want it to be in order to save yourself the extra step, particularly in situations where you have 50 or more locations that you have to place. As previously stated, when you place a pin, you are able to use that pin to recall where you were when you originally printed it. So for example, if this was my view, I added a pin location and then moved the view. By clicking on that pin, you will return to the original location that you had. This is not so for the remainder of the tools, which are designed to fit the tool within the view frame. So now to move on to our line tools. Lines can be created and used for a variety of functions and have similar functionality to the point tool and the path measurement. So a line is placed by simply clicking all of the points that you want to add to your line. They can also be placed by holding the mouse down and dragging through a distance. This can create smoother surfaces, but it also creates a significant number of points which can sometimes be difficult to work with later on. So do be careful when trying to do a large line. Additionally, if you've created a line with too many points, rather than trying to individually get rid of them, you can cancel the entire line and start over again. There are some basic functions included with the line allowing you to change the color as well as the thickness and the opacity of that line, similar to your point tool. And to reiterate, when placing a line, since the click and drag function will add points, you are unable to move the mouse in order to move the frame around it. Your best methodology in order to follow a line, if it needed to cross over into an area that you're not looking at, is to zoom out on the opposing side and then zoom in to the area that you're looking at. This can help to make significantly longer lines without needing to look at them from a really, really high angle. Finally, there is one special case for lines that can be created in a way that requires the measurement tool. By going into the measurement tool, this is applicable to any measurement tool, but is most exemplified by the circle. Once you've created a measurement, you are able to save that measurement and it will be converted into a line. So in this case, you've now created a circle, which if you look very closely, will actually have a tremendous number of individual points that created. So if you did at any point want to modify this circle, however, you would be required to essentially create a new one, since you would not be able to effectively move all of these points in and or out to create a new sized circle. Now that we've covered the line tool, let's move on to the polygon tool. Polygons are remarkably similar to lines, but do have some additional considerations. Placing a polygon is very similar to a line, where you click individual points and construct the polygon internally. However, differently from a line, it can be very important to make sure you are placing your points on the right side. So for example, points are being placed counterclockwise, but if I tried to place a point on the clockwise side, you would see that I would distort the whole shape of the polygon because it is assuming that they remain in order. It will not reorder points in order to create the polygon. This can be useful in some applications, but frustrating in others, so make sure you're looking where you've actually selected your point. The polygon tool allows you to set the color, opacity, and character of both the line and the internal shape. So you're given the option to either have a filled shape with no line, an outline, or the combination of both. You're also given the opportunity to change one separately from the others, so that if you needed an object that was rimmed with a different color, that would be an option. You're also able to change the opacity of each one of them to be separate. So if you needed a hard outline with a translucent inside, that is an option. Now, unlike lines, it is very important to make sure that your altitude is set to an appropriate level when we're looking at polygons. For anyone using the system with no terrain and no 3D buildings, it will typically be unimportant where the polygon has been placed. If it's clamped to ground, you will see it as you pictured here. However, if you've moved it to a relative to ground position and you have your terrain on, you can automatically see that portions of the polygon are missing because they're below the ground surface. To give you an example, a few existing polygons have been created in this area. As you can see, the yellow polygon is on top, but the red polygon is actually showing through on its perimeter. So any lower polygon will still show through the upper polygon on its actual perimeter outline. In order to prevent this, you would have to go into the properties and make it a filled polygon rather than a filled and outlined polygon. Additionally, if you go into the attributes of a polygon, under the altitude you will also see a draw order. So by changing the draw order for any polygons that are at the same height, you will put one or the other ahead. If one of the polygons is at a higher elevation, it will always show before the polygon below it. So the draw order only applies for two shapes that are occupying the same vertical level. And finally, when it comes to polygons, but also when it comes to lines, if you go into properties and next to altitude you check measurements, you will actually be able to find the perimeter and area as well as the length with lines. Similar to your measurement tool, you can actually use these lines to measure your overall distances. So for example, if you had created a line of a given length and you wanted to know how many meters of road were there, going into your measurements would give you a precise measurement of how long that line is. And finally, now that we've covered the basic tools, we have one of the most effective, but yet most challenging tools that's available, the overlay tool. The overlay tool allows you to select an image from your computer and overlay it onto the ground in order to represent what that site space will eventually look like. Now, similarly to the functions that we looked at for polygons, draw order and elevation will be incredibly important for your overlay. It will clip through the ground similar to a polygon and will be either covered or will cover up other objects based off their draw order if they're coincident with each other in elevation. So often what you'll want to do is look at the altitude and move it to an absolute level, which you would want to be a few meters above the ground surface in order to make sure that it doesn't clip through any of the existing terrain or interfere with any of your other drawings on the ground. Alternatively, you could clamp it to the ground in order to make all of your other lines and polygons pop above the overlay. When two overlays are constructed at the same elevation and draw order, the order in which they appear will depend on the order in which they are selected. The most recent overlay will always go to the top. So if I add a new overlay at the same location, elevation, and draw order, you will see that it appears on top, even as it is turned off and back on again. But if the original overlay is turned off and then back on, it will appear on top. This can be a quick way to switch back and forth between overlays, but is ultimately less effective than draw order if you want the overlays to remain in that same sequence. Now, there are limitations to the overlay. If you go into Help and then click About Google Earth, you will actually see that there is a maximum texture size that's available for your computer. This will vary based off how powerful your computer is, but typically, most people will have in the range of about 9,000 by 9,000 up to about 20,000 by 20,000. In addition to this, you will want to consider that Google has an absolute limit of about 75 megabytes and about 100 megapixels for a texture size. So regardless of your maximum texture size, you will want to avoid going over those values. So keep in mind that sometimes when you put an overlay down, you may notice that not the entire overlay shows up. For example, in some circumstances, you will see that this upper portion of the overlay is the only piece that actually shows up, and when you go to the properties of that overlay, you will actually see the green outlines which are surrounding nothing, and only this portion is actually generated. What is essentially occurring is that your computer has gone up to its maximum resolution size and then has stopped rendering the image beyond that. In order to fix this issue, typically you can take the photo to an online website that'll allow you to down-res that photo to a resolution that your computer can actually handle. Typically these drawings are so high in resolution that they're actually highly unnecessary for the application of Google Earth. So typically scaling down 50, 60, 70% of the resolution will still make it quite readable in the final output. And there you have it. Those are the basic tools on how to use Google Earth, which we're now going to combine in order to make a more comprehensive site model. So we're going to move to a smaller market, which is more prone for this type of long-term development. And we're going to look at some of the basic functions that you'll want to use on a regular basis in order to develop a site understanding and move from sort of the preliminary stage into a more detailed site model. I would like to say that this is not a prescriptive model for how to use Google Earth. This is simply the most effective way that I've found to use the software in order to support your project team's development, and seems to be applicable to most land development use in Southern Ontario. We're going to pick a development site, which is on the southern end of town, and is currently an empty farm field. So we're now going to look at how you would want to lay out your general folder structure in order to make your KMZ robust and more easily modifiable in the future. First things first, if you scroll all the way down to the bottom of your Google Earth, you will notice this temporary places. You will want to avoid working in the temporary places, as these will all be lost as soon as you close your Google Earth or if it crashes. Typically, it is better to work within My Places, as this will give you the best possibility that Google will remember your data. In a circumstance where you have a complex site that has many different aspects, you will want to make sure that you lay out all of the information in your KMZ in a logical and readable format. So this involves setting things up similar to a file structure where you want to have larger headings and then subheadings within those. I often find it is important to include things together that are going to be used together because it makes it more easy to select them all at once. For example, previous boreholes have all been added to the same file folder, so by clicking on previous boreholes, they will all appear, but none of the other structures on site will appear at the same time. Now, to manage these folders, there are a variety of ways that you can do it. For example, when trying to move something into a folder, it is often easiest, rather than trying to individually move the item to where you want it in a folder, it is often easier to simply drop the items into the new folder in the order you want them in. So if I wanted my stormwater pond details first, I would drop that in, followed by my overall site, which would go above it. Then I could have my previous boreholes, and as you can see, I'm starting to build an order without having to individually move these objects around, because sometimes there's ambiguity about whether I am about to drop into previous boreholes, or if I'm about to drop it into the overall MapleView document, or if I'm about to drop it into overlays. As you can see, these three lines are all incredibly close together and incredibly difficult to tell apart. So typically by dropping something straight onto a folder, you know exactly where it's going to go, and by doing it in the right order, you can easily build out the method you're looking for. From time to time, however, it will be necessary once things have entered your folder to simply move them around into the order you need, whether you want to organize things numerically or from east to west or any other scheme that you have. Often it's easier to get them in there. If there are issues, then you can do some fine, precise movements later on. Additionally, it can be much easier to move things around once they're in a folder, since Google does not allow you to select multiple items and copy them. Instead, the only option is to delete them or combine them into a geometry, which means they cannot be separated later. So typically it's better to move them into a folder. In this case, if I wanted to take a subset of boreholes, I would make a new folder. I would move the 3 or 4 boreholes that I wanted to take, and then I would move that whole subset at the same time. This would also allow me to copy all of those if I needed to, whereas I can't do that without doing it individually otherwise. For example, if I grab these 3, those I can move all at once, but I cannot copy and paste them. Google will not support that. Additionally, when everything is in one folder, you're able to right-click on the folder itself, go to your properties, and then under Style and Color, if required, you would push the Share Style button, which has already been done here, so all of these boreholes have the same style, and you would then be able to set one style that they would all have to match with. Now, if I were to bring in a new borehole that didn't match this style, for example, if I added a generic pin, and then I were to go to Properties, under Style, you would see this box indicating that they do not share a style, but if you click on Share Style, it'll automatically be brought into alignment. And this can be done when you have many different types of boreholes that need to be put into the same format. It is important to note that when sharing style, the first pin within the folder will always be used to force the style upon all lower items. If I were to go in and change the properties of this borehole to have a red icon, and then go to the properties and choose to share the style, it will automatically descend to all of the other boreholes within that folder. Rather than sharing styles, you are instead using the style from one pin in order to override the styles of all of the pins which are below it. We will now remove the styling by simply applying the original white label to reset everything back to normal. When putting together larger sites like this, we want to make sure that our overlays are saved in a robust manner that's going to allow them to be referenced later on. One thing that Google will often do is it will actually break references if you are moving any of the underlying files that were used in order to create the overlay. For example, if I turn on this overlay, you will see that it's broken. You'd be required to go into Properties and go back to browse to where you originally found that overlay. In this case, I will simply look for the existing file that I had, the stormwater management pond, and it will restore it to its original format. However, if you move the overlay to a position that you no longer remember, sometimes your overlays can become broken forever. So it's often best to set a plan when you're saving all of your files originally, and then make sure that none of the higher level folders are changed. Only ever add new folders within those in order to keep all of the old references accurate. Where files do become particularly large and difficult to search through, there is a search bar down at the bottom that can be used to look for certain objects. As long as they're named appropriately, you can try to find different types of overlays or different types of points that you may have placed previously. Now that we've gone over the basics of creating a robust file structure, we will look at the most important skill that you can learn in Google Earth, which is creating an effective overlay. We're going to move to a site that has more precise dimensions in order to make the point clear. This is also a fantastic example of how Google stitches together new and old imagery in order to create a cohesive site image for you to look at. At first glance, this may appear like a fairly normal site, perhaps with a little bit of cloud cover. But if you start to look very closely, you can see that we're actually seeing two entirely different photos that have been stitched together approximately in order to construct what looks like a cohesive site, but is actually two completely different dates in time. You will also notice that if you go back through the satellite imagery, all of those photos are individual points in time and so are therefore not mixed the way that the traditional view is. You will also notice that significant changes can occur when you go from an older version to a newer version. So you do want to be careful, and if you have a site like this, which is particularly changed by the merging of the two images, it may be best to work with a given time in order to have one consistent photo. You may want to make note of which time you used for all of your references, otherwise they may not line up well when looking at different imagery. In order to create an overlay, typically we're starting with a PDF document that's been sent to us with a drawing. So what we'll want to do is open that PDF document, go to the menu button, select Export a PDF, Image, and then JPEG. We'll want to make sure that we're using a JPEG file because typically a TIFF and a PNG are going to be much larger files and are both difficult for Google Earth to use, but also make our file much larger and harder to share via email. So we'll want to export the image, which apparently I am not permitted to do. However, I have previously exported the image already and can use it for the overlay. In order to place an overlay, click on the tool, browse, and then go to where you've stored that image that we exported from our PDF in order to have it populate. Now, it is typically best, whenever possible, to use an overlay which is aligned along the X and Y axis with our actual drawing page. When you have an obliquely set drawing, it can sometimes be difficult to effectively skew it into place. Use whatever is available to you. It is possible to do a diagonal image, but if you have the option of drawings, typically a right-angled version would be more easy to use. In order to start, set your opacity to about 50%. This will vary a little bit depending on how harsh the lines are in your drawing. For example, this is a faded drawing, so I'll increase it a little, and also how unique your individual site features are. You'll want to start by looking for some prominent and easy structures to line up. So for example, you can see that right in and around this northwestern corner of the building, I can see a few of the prominences are almost lined up as is. So I'll move the drawing to the point where those are nearly lined up with where they should be, and I'll then look to see that the southern side of the building is way off from where it needs to be. So I'll begin by dragging that handle downwards, and you'll notice that as you drag the handle on the bottom, the top actually moves slightly away from where it was. So often it's required to pull the handle down, then revert to the other side of the drawing, pull it in the other direction, and repeat that process multiple times until you've accurately lined up with both of the walls. You can attempt to overstretch and then have it be stretched back the other direction, but often it's easier to do this stepwise method in order to avoid overcorrecting at any point. As we get closer and closer to what we're looking at, you will notice that the outline is starting to take a tangible shape, and you're starting to see more and more features on site that are lining up with where we expect them to be on the drawing. This can be a reasonably tedious process, but once you get good at it, it can be done relatively quickly depending on your level of accuracy requirement. Now, for our current purposes, we're going to say that this is close enough, and I have a more precise one that we can use in the future. One of the easiest ways to quickly check whether your overlay is working is to pick a point, particularly a point that has multiple prominent features, and then quickly move your opacity slider from clear all the way up to full opacity. And if you're noticing that edges are moving or jumping out of the way, then odds are you're not lined up. Whereas if you can see a feature, for example, this building prominence down here, that stays exactly the same between our aerial photo and our overlay, odds are you're in the right place. You'll want to do this with a few structures to make sure that you've got a roughly lined up overlay, and then do small modifications as required to make it more precise. Overlays will never be 100% precise, but one thing that is important is that it is best to get a decent overlay, click the OK button, and then go in to readjust that overlay. If at any point during the initial setting of the overlay, if you click the cancel button, it will entirely delete your progress. So often it's better to get a rough line, set it to be an existing feature, and then go in and edit its properties, because you are then more easily able to make adjustments, and if you accidentally click cancel, it'll go back to where you originally were rather than resetting all of your progress. You will notice that no matter how close you get, your overlays will never be perfect. It is possible for some drafting departments to create overlays that are more accurate. However, the Google Earth dataset is inherently inaccurate, and you will only be able to get so much accuracy out of it. This is why Google Earth is really more intended for project collaboration, sending point data, and working with a project team rather than actually doing surveying, drafting, or any other type of precise real-world measurements. Often it's important to go from an overlay, which has your point data, your line data. For example, in the case of an investigation where you may have borehole locations, you may have prominent site features that need to be surveyed. Those locations should be sent to your drafting department first to be verified against the drawings before any site work is done. In some circumstances, bad overlays on top of the inherent lack of reliability in having large points on precise figures can sometimes mean that your points will be up to 15 or more feet away from where they should be in the real world. In some cases, I have seen points that were actually 50 feet away from where they should be because the reference wasn't to the correct driveway. So it is always important to make sure that we're using our CAD and GIS people whenever we're going from our theoretical planning into the real world. One advantage that we can use with overlays is that if you have an existing overlay that's working and you have another overlay which is the same size and dimension but has different content, you are able to actually duplicate that overlay. So in this case, I'll create a new version of it and then go and use that other drawing of the same dimension, and it will be lined up in exactly the same spot. So in this case, I've laid out the electrical lines on the site, which is the same drawing but with a markup. Now this does require the drawings be exactly the same size. So typically this will be a rare circumstance where somebody has created a drawing set rather than a circumstance where you have various project drawings from various different stakeholders. In some circumstances, you will need to make minor adjustments, but typically they should be fairly well lined up. So now we're going to look and see that we've got a variety of different overlays that have been created for the site, where you can see the building itself, you have red for electrical, and you have blue for your sewer alignments. Once we have this, we can then move from our overlay into our point, line, and polygon data. In this case, we would be looking at line data, so if we wanted to create a path, we could then go in and trace out some of these alignments in order to be able to see them more clearly when the overlay is turned off. This makes for sometimes effective imagery, but also can allow us to look at different data sets side by side. So again, I've gone through and traced out all of these various paths on the overlay, so we have, in this case, all of the electrical lines. Now, when you have a situation where you only really want to look at one set of data at a time, there is an option by going into a folder, selecting its properties. There is a drop-down that says Show Content as Options, also known as the radio button selection. When this is activated, instead of being able to activate both, in this case the electrical and the sewer, by clicking on one and then the other, it will toggle the previous result. This way you can look at the electrical and then look at the sewer without needing to rigorously click back and forth. However, you can turn this option off at any time and easily be able to look at them both at the same time. So now that we've covered some of the basics of how we would do an overlay and how we would go about putting line data on top of it, let's look at a more complex example where we have a variety of overlays in that southern portion of the town where we have the new development site. In this case, there are several overlays, one being the main site area, another being our previous boreholes from a different drilling operation that was completed, another being natural heritage, which was an assessment done by a subconsultant, and another being the functional servicing report, which was the original civil design that was done for the site. On top of that, there is a smaller drawing of a stormwater management pond that was done for a portion of the detailed work. Now we have radio buttons activated so that we can look at each of these overlays individually and compare them to whatever data set we're currently working with, whether it be a set of new boreholes or, in some cases, if we're looking at a revision to the functional servicing report alignment, we could create the original alignment and then look at that in relation to the other site features. And with all that being said about overlays, it is very important to remember not to mess with a good overlay. Google Earth is ultimately an imprecise science, and we will never get perfect overlays with this method. Sometimes making a small adjustment to an overlay can result in a significant amount of time in order to make it back to the original shape that we had. So if it's necessary to make a change to an overlay that is acceptably prepared, make sure to create a copy of it or simply save your files first before making that change in case you need to revert back. Now that we've finished with overlays, it's time to talk about creating and managing point data, which is an incredibly important part of the KMZ process as it allows communication between the various project team members and often lays out investigation locations that are required for our fieldwork. So as previously stated, when you place a place mark, which can either be done by pushing the button or Control-Shift-P, you will want to then name your object first before moving it in order to have a level of expedience rather than having to place the object and then go back to your properties to give it a name. I'm going to delete these 2 point items, which, as you can tell, has to be done individually. And then we're going to talk about various naming conventions. So typically it's best to put most of the information that you want within the borehole name. For example, borehole 5 meters, perhaps it would be a monitoring well, perhaps it would be an environmental location. You can use descriptions in order to add to the information on the borehole. You could say that, this will be limited access. This is a good way to add additional information. However, you'll note that it takes a significant amount of space on the Places tab over on the left-hand side. So if each borehole has a description added to it, it can create a somewhat unreadable file structure. And so often it is better to limit the data that's included to what's actually in the file name and put any other notes outside of the KMZ document. Often it is better to come in and give generic names, such as each one being a borehole of no description. And then once you've laid out the locations, you've made sure that you're happy with how far apart they all are or how spaced they are from a given site object. Then you can go in and individually rename them to give them the details they need, or perhaps give them numbers and other information that would be relevant to your project work. This method often creates the least amount of headache and hassle because sometimes you'll place more boreholes than you need, or you'll place them in locations where the numbering would not be logical if followed in the order they were placed. Typically, it's better to start with general and move towards specific. It also is a lot easier to click on a location and use the Alt-Enter shortcut in order to open its properties rather than trying to right-click on each individual one, particularly where you have clustered data and it can sometimes be hard to click on the correct place mark. Additionally, when you're placing locations, try to avoid using the actual push pin shaped objects. As you can see, when I place a push pin, it will actually move a very small amount. That is because the push pin is actually centered in the middle of the object, not where you see the pin connect. So that can become somewhat deceiving, particularly when you're out at large distances like this, because where in that pin you're actually looking will change. Whereas when you see I highlight these flatter objects, they do not move the way the pin does. So typically it's better to avoid and better to use one of the flatter icons. So for example, the circle, the square, the empty circle, the diamond, or the triangle, as these are nice and flat and allow for flat colors as well, which are easier for contrast. Where larger data sets exist, it is possible to actually import data directly into Google Earth without having to place it individually each time you're setting a new location. Importation must be done using a comma-separated value or CSV file, and the locations must either be in lat-long coordinates or as a site address, but you're not able to use UTM coordinates or any other method for placing the points. Typically, your drafting department will be able to provide the CSV file based off known point data wherever they have it. Often, it is better to have the drafting department split the data out for you if there are any ways that you want it to be later segregated on Google Earth. For example, if you have manhole locations and water valve locations, it is often best to have those as separate data sets so that they are imported separately and then can be used separately without having to be manually pulled apart. In our first example, we're going to use addresses, which is as simple as it sounds. By placing a civic address, you're able to have a point automatically placed on the map. So in this example, we'll want comma separated because we're talking about a CSV or comma separated value file. You can already see that it's broken down the various IDs that were within the original CSV file. So we're going to hit next, and you will then see that this is a street addresses file and has already identified that, but you may need to click this button in order to have it look for addresses if it doesn't automatically recognize them. The only important factor to remember is that addresses cannot include any commas. So this is something that your drafting department will need to account for, or else you will have several individual columns that will be generated. This can be easily done in the actual CSV file. It can also be done manually yourself if it's been forgotten earlier, but is always easier to have pre-prepared. In this example, you will see that Google Earth is actually describing this process as ingesting. It's something to keep in mind that importing and ingesting are the same in terms of Google's terminology. And in order to apply the style, I'm not going to do that at this time. So you will notice that it actually generates all of these locations, but it has them turned off. So we're simply going to turn them on. And you can see that we have 5 points scattered throughout the GTA, each based off the address that was originally supplied. So now we will delete these locations, and we will move back to our development site. So now we're going to import a more detailed data set using the lat-long method. So we'll go to import and select our new file. And as you can see, we've got a name, a latitude, longitude, but also a color and icon column, which can be defined by either your drafting team or by you manually within the CSV file. So by moving through, we can see that we're looking at a lat and long data rather than an address, and that it's collected all of the various fields. Once we click finish, it'll ask if we want to apply a style template. If we say yes, it will give us the option to actually apply styling automatically. So for the name of the individual icons, we'll want to use name, which will apply to each individual point based off that field. Then we'll want to look at color, which can either be used for a single color or can be set based off the field. In this case, we're going to use the color field to set the color of each individual, which unfortunately must be done with a ranged palette. So for example, if you go from yellow to green, it will give all of the various colors within that range. And if you look for the individual color codes, in this case 1 and 2, you have to pick from that palette range. So typically, I find it's best to use blue and red, since they're so far apart on the palette scale that it generates virtually all the colors that you might need of the rainbow. You are missing purple and a variety of others, but this does give enough differentiation that you can select unique colors that won't overlap with each other. In order to do this process effectively, you will want to make sure that you have fairly simple breakdowns for color and icon, typically done in numbers, but can also be done with symbols, as long as they are simple and straightforward in order to break down the various types. Then by moving on to icon, we can do the same thing and use set icon from field, select the icon field, and then give an individual icon for each of the selected options. So in this case, we would want to actually use the 2 different circle types to represent the different icons. From there, you are able to actually set a height above ground if that's something that's relevant to your data set, but it's not something we're going to do today. When you click OK, it will ask you if you want to save your style template, which is not necessary. Simply click cancel, and it will generate your data set. Again, all of your points are going to begin unchecked, so you'll actually have to check them off in order to see them appear in the real world. And now, as you can tell, I have some of the manholes in one styling, and that would be the internal manholes to the site, and I have the other manholes in a different styling scheme because they are external to the site. By taking all this data and incorporating it into our file structure, you can end up with something like this, where you have a trunk sewer folder that would have the trunk sewer alignment, and then under manholes, you would have internal manholes that can be identified separately from the external manholes. This gives the maximum control over which different piece of data you want to look at a given time, allows for styling changes individually, and allows for all of it to be turned on and off with a click of a button. Now that we've seen how to place our data, how to work with data sets, and how to create effective overlays, it's time to talk about how to export our data and share it with others. Firstly, there are very basic mechanics behind how a Google Earth file actually works. So for example, in order to save a different portion of a Google Earth folder, you would simply go to the overall header, right-click on it, and go to Save Place As. So we're going to work with a slightly more simplified set. We'll work with the previous boreholes. We will save the place as, and just simply going to save it on the desktop as previous boreholes. Your options are either a KMZ file or a KML file. The difference is that a KMZ file would be one that includes photos and other more detailed information, whereas a KML file is a more simplified version that only has the point line data in it because it is a text file only. So if we save a KML file, we can actually go in, and I will open the KML file outside of Google Earth in order to show that within that KML, there is actually a variety of point information that has included all of the individual place marks that are within that KML. So if we wanted, we could pull the individual coordinates of a given place mark straight from our KML document. It also gives other information such as the altitude and some of the other basic points that were included with that data. This can be an incredibly useful way to work with a detailed set of information and make minor changes if required to a data set, but do be careful because changing the wrong information could break the KML file, so always keep your original. For a slightly more detailed example, if we were to save the overall file as a KMZ file, this would include all of the supporting data that goes into it, including our overlay images. Try not to rely on this, as sometimes sending a KMZ file will only include the overlay for a certain amount of time, but over a repeated exposure and opening that file, saving it to other places, occasionally those references can become broken, and without the original file, you won't be able to restore your overlays. If you go and look at the same KMZ file that corresponds to that KML, if you look under the open with, you will not be able to open it in a notepad because it does contain image information. However, you can actually convert your KMZ file to a zip file, which is the only aspect that is actually included in a KMZ. It is simply a KML document that then has files associated with it. So here you see all of the image files that are my overlays, and then outside you have your document file, which would ultimately be the same document that we just looked at, but with additional point data that came from the other folders. Most of the time, this will not be necessary for you to use individually. Simply saving a KMZ and sending it to another user for them to open it in GoogleEarth is typically more than sufficient. In those circumstances where you've been asked to send point data to somebody else in the project team, you would simply click on the folder, right-click, and go to Save Place As. You'll want to save as a KMZ typically because they are the more robust file type, and if you have forgotten that there's overlays or other information included, the KML will not capture that. So simply save it as previous boreholes for project, and then send that file to anybody else who either uses a Google Earth platform, or if you send it to somebody who uses CAD or GIS, they are similarly able to pull that data format into whatever they're using and modify it from there. So for example, you may save the KMZ of your boreholes and send it off to the drafting department so that they can compare it with the original CAD drawings. In some circumstances, you can go online and find tools to convert KMZ and KML files into CSV files if they're more easy to use. However, be careful where you're using these and make sure that these websites are approved by your company's IT before accessing them. Outside of working with the raw data, it is often necessary to create prepared site photos that can be included in reports or used to share with people who don't require all of the background information. So there are two ways that this can be done, which ultimately work out to a very similar functionality. So firstly, we're going to center ourselves over the previously identified trunk sewer area, which is the one that we want to export and send off to another member of the project team. So by clicking Control-Alt-S, you will be presented with an option to save as an image. Alternatively, you can use Control-P, which will allow you to save directly as a PDF. But there are some slight limitations associated with this, such as needing to actually meet the dimensions of an individual page, whereas the image can be done to the full size of your viewing port. Alternatively, from pushing Control-Alt-S, you can click the map with the place mark in it, which will toggle the same functionality. Be careful, the button next to it, View in Google Maps, will open a new web browser and take you to that location within Google Maps, and they are very easy to confuse back and forth. If you do require additional horizontal room, it's possible to turn off the side panel on the left side using this button that is next to Placemark. This will give additional horizontal space, but also creates an aspect ratio that is somewhat impractical for most project use. You will also notice that the viewport has zoomed in slightly and will need to be manually adjusted to fit all of the same elements. You will also need to readjust the viewport if at some point you choose to turn the side panel back on for your exports. Options are available to give the title of the figure, as well as a description to go along with it, and a legend item. Now, the legend can be somewhat cumbersome, but ultimately functions by looking at all of the available place marks and other structures that you have and listing them on the legend. Now, the limitations come in where if I were to move my screen and then refresh from view, I will lose the internal manholes because they're no longer shown. So I would have to move my cursor back over to that area and refresh from view to get it again. If, in this circumstance, I had already created a name for this structure and then I went to try and reincorporate the internal manholes, it would actually reset all of my original naming. So do be careful when going through this process. Also, as previously stated, if you have any place marks that have a visibility of 0, they will not show up in the legend. But if they have a visibility of 1, they will show up in the legend, which can sometimes allow you to include place marks or lines that you want as a legend item, but may not necessarily be visible in that given location. So for example, you would potentially name these external and these two internal, and we then have our alignment. Once we've set our legend, our name, and our description, under map options, you will find the ability to increase the scale of those items in order to make them more viewable. You are also able to move any of these items around the screen at will, but they are typically best aligned where they exist, and it's often only necessary to move the scale bar, north arrow, and Google Earth images as they get in your way. In certain circumstances where you don't want any of this existing information to be included, you can actually go to the map options and set your scale to be 1 and effectively turn all of them off. It is in fact the only way to get rid of the Google Earth image. As you can tell, it is not a selectable option. This Google Earth icon will always be there unless you've turned off effectively all of the elements. So we're going to set our scale to be 150 in this case, and then we're going to center our drawing the best way that we can. Sometimes you will find that individual place marks will be improperly aligned or will be overlapping other place marks and or leaving your screen. What can sometimes be done is by taking a new place mark, moving it into the location of that existing place mark, you can actually push its label to a new location. You don't have to place this place mark, but it can be used to nudge them as required if they're in an awkward position. Once you're ready to save, you are able to save the image directly, put it wherever you would like in your folder, but you are also able to save the actual settings associated with this export. By going to map options and then clicking save, you will be able to save a Google Earth print, which effectively locks in where you are on the screen, what information you have in all of your supporting information, and the scales that they have. But what it does not do is save any of the place marks that are currently active. So if I were to save this and then reload it later, these place marks may not be here and would have to be restored. So something to consider is that the only details you're able to save are the actual overlays that would appear and disappear when turning off the saving function. Now for some minor final points related to exporting your images. Under the map options, there is an HTML area. This can be used to either pull information from an external website or to display information such as text or your company logo. However, more often than not, for most users, it is easier to create an image export and then simply add information on top of that image rather than working with the cumbersome nature of the HTML. Keep in mind also, if you completely empty the HTML area, it is then no longer editable, and you would have to completely restart Google Earth in order to get the HTML area back. Aside from that, there is also some tips and tricks to get an effective screenshot, including the earlier tips about trying to move around the various place marks to fit, but also using the plus and minus button to very precisely outline what you're looking at when your mouse scroll wheel makes it difficult to effectively capture without having wasted space or cutting off individual elements. Additionally, your legend items will always be placed in alphabetical order regardless of what type they are and what general use they have. So in certain cases where it's essential to have them in a certain order, it may be necessary to actually add numbers to the beginning, which would allow you to choose a precise order that they be placed. Also keeping in mind that sometimes you will click on the wrong element because when you've renamed one element, they will all rearrange when you go to click another one. So do be careful that you don't unintentionally change the wrong element because they've shifted since the last time you looked at them. Although images are the most useful type of export, the PDF export can be used and is simply a matter of choosing the right page layout, which will more often than not be the 11:17 layout since it covers more of the viewport and allows you to capture images more effectively. This can be a good method if you're going to be sending these as a file rather than including them in other documents or trying to put them as part of text. With that, we've completed all of the basic uses for Google Earth. We've covered the different types of tools that you may require. We've covered the methods of overlays and the importance of having effective, robust overlays. We've talked about importing data and how to use and share point data. So the last thing to cover is best practices for how to manage large KMZ files across a project team. First and foremost, making sure that you're saving your files often. Google Earth does have a tendency to crash and also has a tendency to lose the data that you've put even in the My Places section of your Google Earth portfolio. I often find that it is worth going to the Google Earth local data, which is located in the link that you see on your screen under your user profile, AppData, LocalLow, Google, and then Google Earth, and saving this data somewhere to your machine separately on a semi-regular basis. This will mean that if Google does lose all of your data, you'll be able to go back to your most recent backup and at least get to restart from, say, 1 week or 1 month ago rather than losing everything that you had in your profile. In order to save an overall project rather than your entire file suite, you'll want to make sure you're clicking on the highest level folder, right-clicking on it and going to Save Place As. You will then want to find a location to save it and make sure that you're saving several iterations of the file rather than simply saving over the same one progressively. Often what will happen is a overlay or other tool will become broken, and in saving over the existing file, you will actually lose that data and be unable to go back for it. So my favorite method is to create a new folder called Previous, and then each time you would go to save it, you would save it with your existing date. In this case, it is currently May 10th of 2024. You would save that file, and then when you went in, did additional work the following day, you would go and save that file again, and you would move this existing file into your previous, and then when you're saving it on the next day, increment the date. That way you have a constant log of the daily saves that you've done along the way. And when that becomes too large, you would go back and delete old data so that you're saving at least 5 or 6 iterations of your project in case anything were to go wrong. Often it's best to stick with your current version, even if it has broken overlays or other tools, and then go back to an older version to pull out individual sections that are no longer working and transplant them into your new file. Also, as previously stated, making sure that you're not changing your file structure for where you have your overlays saved. If an overlay is no longer properly referenced, it will show up as a large X through a white box, and you will then have to go and find the original image file in order to restore that overlay. So making sure that when you place an overlay into a file, you've consciously considered where it's going and are going to go out of your way to avoid changing that location into the future. And then finally, working with a project team can be complex. So consider when you are saving things, you're going to have a previous folder that's going to have different versions in it. And it may be worth actually saving them by the date, but then also by the individual that worked on it. That way, if you have multiple competing versions of a KMZ, you can always sort out which ones were worked on by which staff and hopefully recombine them into a master KMZ at a later date. It may also be best to have one member of the project team that is responsible for the master KMZ and then pulls in individual pieces that other people work on and keeps an up-to-date copy so that people can always pull the most recent version for their site work. This will be individual based off your organizational structure and the project that you're working on. And there you have it, Google Earth for land development. All of the tips, tricks, and tools that you may need to use Google Earth in your everyday land development activities. I hope this guide has been helpful and serves you well in the future.